welcome to my channel, and here we will be working on this particular problem. So we have it on page 109 of Engineering Drawing Book 2. As we have here, we looking at the elevation of a truncated oblique cone. Elevation of a truncated oblique cone, and what we are required to do is to develop the surface of this particular shape. And as you can see here for the dimensions, we have that the circular base of the oblique cone has a diameter 70, and for us to get this point, we have this point, which is also, let's say at this point, distance from here to here is 20 millimeters. The height from here to here is 56, and distance of this point from here for us to get this particular curve is 54, and the distance from here up for us to get this, be able to draw this point or this curve, is 44, and the radius of this curve is 32 millimeters, and the angle at which this particular line inclined is 30 degrees to the horizontal, and then we're asked to open it along this part A in here. So that is where we have the seam. Okay, so we are going to make use of these dimensions. First of all, to produce this shape, then we go on and produce the surface development of this particular truncated oblique cone. So let's start. So the first thing that we are going to do here is to draw a horizontal line, center line like this. Okay, then we draw a vertical center line, so not taking it up, so we just stay somewhere around here, and then we take this down. Okay, so the next thing that I'm going to do is to take the radius of the circular base of the cone, which is 35 millimeters. The diameter is 70, so the radius is 35 millimeters. So I will take 35 millimeters, so like this. Okay, then I'm going to draw a semicircle here. So we draw a semicircle, and this semicircle I'm going to divide it into 6 equal parts. So here we have this point, and here we draw here and to this side, and then so putting at this point we draw this. So we have divided it into 6 equal parts. So I'm going to number this. So this is 0, so this is 1, this is 2, and this is 3. Okay, so this is 4, this is 5, and this is 6. Alright, so we have numbered the points. So the next thing that we are going to do is that we need to produce the front elevation, and for us to be able to do that, so we need to extend this this horizontal center line. So I need to extend it a bit, and I'm going to take a measurement of 20 millimeters from this point, 20 millimeters from this point to this side here, and I'm going to draw a vertical line from this point. So I draw a vertical line from this point up, so it goes like this. Then I'm going to take a measurement of 54 millimeters, a measurement of 54 millimeters. Okay, alright, so I'll take a measurement of 56 millimeters. So I'll take a measurement of 56 millimeters from this point up. So this is 56 millimeters here. So the next thing I'm going to do is that I'm going to connect this point together. This point 0 I will connect together with this point. Okay, then also this point I will connect it together. So from here, that is point 6 here, I will connect it together with this point. Alright, so the next that we are going to do is that we need to draw that particular line that is inclined at an angle 30 degrees to the horizontal, and then before that I need to draw this center line, the center line of the oblique cone, I need to draw it. So like this. Okay, so because the line that is inclined at an angle 30 is start from this point. So what I just need to do is to take my 30-degree set square and putting it at this point here. So setting it at this point. So setting it at this point, I'm going to draw the line. So I'm going to draw the line. So we draw the line from here to here. So this is the line. So the line is inclined at an angle 30 degree to the horizontal. So I'm going to make this line a thick line. So from here up, so I'll make it a thick line like this. Okay, so the next thing that we are going to do is that we need to draw the curve. We need to draw the curve. So, and as I said, so we are going to draw a horizontal line. So from this point, we draw a horizontal line from here. From this point, we draw a horizontal line. So going to this side. Then we are going to take a measurement of 54 millimeters so that we can draw the curve 54 millimeters. Okay. Alright, so this is 54 millimeters here. So, and again, that's the ink is. Alright, so this is 54. Then I'm going to take a measurement of 44 millimeters. So along this line, I will take 44 millimeters. So this is 44 millimeters. Okay, so from this point, I need to draw a vertical line down here. And then from where we have this 44 millimeters, I will just draw horizontal line like this. So that's where they intersect. So the next thing I'm going to do is to take a measurement of 32 millimeters as the radius of the curve. So 32 millimeters as the radius of the curve. So I will take 32 millimeters here. Then, so I put at this point, and okay. So 32 millimeters. So I put it at this point here. Then we draw the curve. We draw the curve. So it goes like this. Alright, so we have drawn the curve. So we have drawn the curve. So the next thing that I'm going to do is that, so I'm going to make this line. So from here down, a thick line from here to here, and then so from here up we make it a thick line from here to here, and then the base also, so we also make it a thick line, so that is from here to here. Alright, so then the next thing that we are going to do is that we need to project these points. We need to take them up. We need to take them up so that we can draw them into the elevation of the oblique cone. So we draw a vertical line to touch that horizontal line. And from here also, we also draw a vertical line to touch horizontal line from 4. So we do the same. And also from 5, we also do the same. Alright, so the next thing that I'm going to do here is that, so I'm going to connect this point with the apex of the cone. So we also join this point together, and then so we connect this point also together, and then so the last one here, so we connect it together with the apex of the cone. Alright, so looking at what we have here, so this is the shape that we are given. So the next thing that we are going to do is to draw the surface development of the oblique cone, or of the truncated cone, as we can see here. Alright, so before we can do the surface development, this is an oblique cone, so we need to find the true length of each of this line. We need to find the true length. So very, very important. We need to find the true length. So that's the next thing we are going to do now before we go on to develop the surface of this truncated oblique cone. So to find the true length, so I need to extend this line, and this is the way I usually do it here when it's come to finding the true length. So what I will do is that, so I will put a point on my compass at this point here. Okay, so let me call this point, let's call this point as point O here, and let's call this one, let's call it point A. Okay, so what I'm going to do now is that I'll put the point on my compass at A and extend to 0. Then I will turn it to this side and make an arc here. So this is 0 prime, 0 prime. Then from A again, I will extend it to 1 here. So extend it to 1, and then I will make an arc here. So this will be point 1 prime for the true length that we have to find for each of this line. Okay, so the next thing is I'll put it at A again and extend it to 2. Then I'll make an arc here on this line. So this point will be point 2 prime. So I'm going to do the same thing for the rest while I pause the video, and when I'm done with that, I'll come back and show you the next thing to do. Alright, so with what I've done here, so all I need to do now is to connect this point together with point O, and that is what I'm doing now. So each of this line is the true length of each of this line that we have here. So, and we have point 2. So for any oblique cone, for the surface development of any oblique cone, you have to find the true length, including oblique pyramid too. So you need to find the true length. Very, very important. You need to do that, and that is what I have done here, which you have seen how to go about it. So after this now, so I need to connect point 5 together with point O on the apex of the cone. So then point 6, I also need to connect it together with the apex of the cone. So then after we have joined all the line with point O, the apex of the cone, the next thing that we are going to do is to go for the surface development, and this is how it goes. So don't forget that each of these lines represent the true length of these lines. So that is how we do it here. So next thing that I'm going to do is that for surface development, I'm going to draw a line. So I will come up like this. I believe you can see this. So I'll come up like this, and then I will draw horizontal line. So from this point, I'll draw horizontal line like this. Okay. So now, so this point here, so this point is going to be point O as we have here. Don't forget that this is where we have the seam as shown to us in the diagram. Let me even write A here. So this is A, and this is also point A. So we are asked to use this part to cut it here and open it. That's what we want to do right now. Alright, so what we are going to do now, so we take distance O6 prime, O6 prime, because that's the longest true length, and that is what we are to take. So we take distance O6 prime, so like this. Okay, so we take it here, then we put it at this point O here, and we are going to draw an arc. So we draw an arc like this. Okay, so the arc goes like this. I believe you can see it. So now, so we have this point now, because this is point O here. So I'm going to label this point as point O. So that's what I'm going to do. So now, so the next thing that we are going to do is that we take distance 0, 1 or 1, 2, anyone that we like, or 2, 3, anyone that you like, just take it. So I'm going to take distance 2, 3 like this on this arc, on the semicircle. So then I will put it here and make 12 arcs here. 12 arcs, that is 1, and this is 2. So we go on like that until you get to 12. So I pause the video and do that. Alright, so I've done some things behind, apart from obtaining the 12 points on this arc, as you can see here. So I've done that, and I've numbered 0 0 1 1 2 2 3 3 4 4 5 5, and then we have 6 here, because by the time we cut it here, 6 will be in the middle, and that's why we have it at this point. So the next thing that we have done is that I've connected each of these points with this point O here, so which I believe you can do yourself. So the next thing that we are going to do is that we need to obtain each of these points here on this part here, on this surface here. As I said, so the length that we use is the longest one, which is 06 prime. So all these ones from 0 prime to 5 prime, they are shorter than that of 06 prime. So what we need to do now is that we take the distance from point O to O prime here like this. Okay, then we put it at this point O here. Then we make an arc here, and here also we make an arc. So we do the same thing from O1 prime, O1 prime like this. We take this distance, then we put it at this point O here. So we put it at this point, then make an arc on this line. So we make an arc on this line. So we continue like that until we get to 5. So that of 6 is going to end at this point. So that we need to get that of 0 prime to 5 prime. Okay, so I'm going to pause the video and do that. All right, I'm sorry, I'm not supposed to go in that process. I thought it's a complete oblique cone. I've forgotten that it's a truncated one. So so please pardon me for that. So what we need to do now is to take from O to this point 0 here. So this point goes with 0. So we take this distance. Okay, so if we bring it here, we also have it at the same point. So I'll just be taking it on this main view. So we put it at this point here. So then we make an arc on O here, make an arc on O here. Okay, so that's the point that we need. All these ones we don't need them. So then from this point O again to this point on 1, that is this point that we have here, this particular point. So we take it like this and we bring it to this point here. Bring it to this point O here. We make an arc on 1 like this, also on 1 here. Okay, so next from O again, so to this point on 2, this is the point, this is where we have it. So we put it at this point O here, and we make an arc on 2. Here we also make an arc on 2 here. So then again, from this point O here to 3, so 3 is actually, this is where we have 3, so that is this point here. So to this point, so we put it at point O here, and we make an arc here on 3, and we also make an arc here on 3. Okay, so then for 4, so I can even take that of 4 on this line. So so I'll just extend it here, and then so putting it at this point here, so I'll make an arc here on 4, I'll make an arc here on 4. Then that of 5, so also from O to 5, I can take it on this side if I like. So I'll just bring it here. So taking the distance, so putting it at this point, so I make an arc here on 5, and make an arc here on 5. So that of 6 will land here, so I don't have to do that. So so let's dot the point out. So let's dot the point out. So this is the point, this point, this point, so this point, this point, and here we have the point here, this point, this point, this point, this point, and this point here. Alright, so what we need to do now, so we are not done with everything, so I just need to connect this point together first. So we make this will be a thick line, and this will also be a thick line from here to here, like this. Okay, so other part we use the French curve to connect them together. So So looking at this point, so these 4 points, so I can connect them. So let me connect these 3 first. So we have this being joined together like this. Then, so I can connect the 4th one like this. Okay. So then, so alright, so these 3 points I can connect them together like this. Alright, so then I can connect this point together with point 6 here. Alright, so and then so connecting these 3 points together. Okay, so then connect so this point together. Alright, so this is how this shape is going to be. What about this particular part that is cut off? So that's going to be within here. So let's quickly do that. So what we need to do now is that, so from this point over here, I will extend to this point, So to this point that we have on this center line, so I will extend to this point. So it's on the center line, that's on 3. So I'll put it at this point over here. Okay, so I'll make an arc on 3. So this is point 3. And also we also have 3 at this point here. So the next is so from here again. So we also have this point on 3. So this particular point on 3. So I'm doing the same, doing that at the same time. So we also have this point here, and we have a point here on 3. Then the next is, so we have this point on 4, so which is this point here on 4. So we take this distance on 4. So we make an arc here on 4, and we also make an arc here on 4. So there's another point that we also have on 4, as we have that of 3, so which is this point here, which is this point. Okay, so we take this distance, so from here to here, so we make an arc here on 4, and we also make an arc here on 4. Then we have that of 5, so which is first of all this point here. So we have this point. So we make an arc here on 5, make an arc here on 5, and then so here we also extend it here. So make an arc here on 5, make an arc here on 5. So the last one is that of 6. So I need to take distance from here to here, from O to this point on 6, and then I will put it here at this point. So make an arc here on 6. Then from O again to this point on 6. So we make an arc. So putting it here, we make an arc here on 6. So all these points, we are to join them together with the use of a French curve. Alright, so as we have the points being arranged like this, so I'm going to connect this point together like this, and then so for this point, okay, so I can join this point together like this. Okay, so then if I bring it here or I turn it here like this, I can join this point together as I did for that one there. Okay, then so come in here. Alright, so we are getting to the final part of this work. And alright, so this how the surface development will look as simple as I've done it here. All you need to do is to practice. Thank you, and God bless you.